Hello, my name is Gabe. For this problem, we're asked to find the standard form of the equation of the hyperbola with vertices at the points 2, 3, and 2, -3, and we also note that our hyperbola passes through the point 0, 5. So how I like to begin any problem like this is I like to start just by sketching a rough graph of whichever conic section we're looking at. In this case, it's a hyperbola. So let's go ahead and let's plot our vertices at the point 2, 3, and 2, -3. Now we also know that our hyperbola is going to pass through the point 0, 5, so let's go ahead and let's put that point up here also. So now if I were to try to sketch the graph of our hyperbola, I know that it would look something like this. And similar down here. So as I said, this is just a really rough sketch of what our hyperbola is going to look like, but it gives us a nice key piece of information, and that is that our hyperbola opens vertically. So we can use that when we try to determine which form of the standard equation we should use. So recall that the standard equation of a hyperbola which opens vertically is given by y minus k, quantity squared, divided by a squared, minus x minus h, quantity squared, divided by b squared, is equal to 1. So our goal here is to find k, h, a, and b. Now, we have a couple different ways that we can go about doing this, but let's start by first finding the center. So we know that the center is going to happen in the midpoint of the line segment joining our two vertices, and we can go through the computation, or we can just look at the graph. And what we'll see from here is that the center of our hyperbola is going to be this point here, the point 2, 0. So what that tells us is that we're going to have the point hk equals 2, 0. And what that implies is that h is equal to 2 and k is equal to 0. So now we found both h and k. Now our next task will be to find a and b. So something else that you want to recall is that this distance between the two vertices is 2a. So thinking about the distance between these two vertices, we can use the distance formula or just look at the graph, and what we'll see is that this distance is 6. So we have 2a equals 6, which means that a is equal to 3. So now we have h and k from the center of our hyperbola, and we know what a is. But just by looking at the graph and the vertices, we really don't have a good way to figure out what b is equal to. So what I'm going to do is I'm actually going to substitute in these points into this equation, and then we're going to use this fact that our hyperbola passes through the point 0, 5 in order to solve for b. So we'll substitute h equals 2, k equals 0, and a equals 3 into this equation. So what we're left with is y minus 0, this quantity squared, divided by a squared, which is 9, minus x minus h, and we know h is 2, this quantity squared, divided by b squared, which is what we're trying to solve for, and we know that this is equal to 1. So as I said, we know that our hyperbola passes through the point 0, 5. So this means that when x is equal to 0, y is equal to 5. So we'll substitute 0 in for x and 5 in for y. And what we're left with is 5 minus 0, this quantity squared is 25, divided by 9. And here we're subtracting 0 minus 2, so -2 squared is 4. divided by b squared. And this is equal to 1. So from here, our goal is to solve for b or b squared. So let's go ahead and let's add 4 divided by b squared from both sides of the equation and subtract 1 from both sides of the equation. So instead of just subtracting 1 from both sides of the equation, let's try to simplify some of the arithmetic, and we'll subtract 9/9. And this is going to be equal to 4 divided by b squared. So what we have on the left-hand side is we're going to have 16/9 is equal to 4 divided by b squared. Now, there's a couple things that we can do here in order to solve for this. Let's take the reciprocal of both sides. So here, if we take the reciprocal of 16/9, this is going to be 9/16. And if we take the reciprocal of 4 divided by b squared, this is going to be b squared divided by 4. Now to solve for b squared, I'll multiply both sides of the equation by 4. So what this tells me is that I have b squared is equal to 9 divided by 4. So at this stage, you could solve for b by taking the square root of both sides, but if you look back at the standard form of the equation, all we need is a b squared. So if I'm going to write down the standard form of the equation, it's going to be given by y minus 0, this quantity squared, divided by a squared, which is 9, minus x minus 2, this quantity squared, divided by b squared, which we found to be 9/4, and this is equal to 1. So here, we can just take this one step further and simplify this y minus 0 squared, and just rewrite this as y squared divided by 9 minus the quantity x minus 2 quantity squared divided by 9/4, and this is equal to 1. So the standard form of the equation of our hyperbola is y squared divided by 9 minus the quantity x minus 2 squared divided by 9/4 is equal to 1. Thank you.